Now here's another interesting observation. Let's go back to 0 again. Okay? So this is 0. Let's just do a rotate to 0. Start with 0, do a single rotate. Okay? Okay, twist. Okay, where are we? No, this isn't 0. We're exactly where we were before. That's sort of strange, isn't it? In fact, you can do another twist. Now, does everybody see what's going to happen? We can do twists till the end of time, and it's not going to change this. So that's another real interesting observation you can make, is that if we start with 0, and this time we did a rotate first rather than a twist, we get to something. I don't know what number this is, but it's a funny number in that if we do any number of twists to it, it's the same thing, right? So but what does twist do to a number? It adds 1. So I don't know what this is. Let's call it U for unknown. I'm just going to assign a name to this. And so if you start with 0, rotate gets you to some unknown number, right? And now what does twist do to U? So U plus 1, but that's the same as U. Okay? So, I took high school algebra. I can solve this. U plus 1 equals U, right? So I'll say U, I'll bring the U's to, what you do, you get the unknowns to the same side. U minus U equals -1. U times 1 minus 1 equals -1. U times 0 equals -1, so U equals -1 over 0. So that's not so good. So this isn't behaving like any number we know, right? I mean, every real number, if you add 1 to it, you get something different. But this is weird in that we've got it can't be a number. I mean, obviously in school you teach, something divided by 0 is undefined, right? But I like, this time maybe it's better to have something else. When I divide a number, let's say I divide a number 1 by 0, that doesn't make any sense. But what if I divide a number by 1 by something that's really close to 0? What do I get here? A big, big number, right? And in fact, the smaller this number gets, the bigger this number gets. So if I let this thing go all the way to 0, how big would this thing be? Sort of grows as big as it sort of grows without bound, right? So it might be reasonable to just call it infinity, if you like. And does that sort of make sense does it sort of make sense that if you start with an infinite number and you add 1, where are you going to be? Is that sort of, I mean, I don't want to be real precise about this, but this is a sort of how you would think about an infinite number, right? It's so big that adding 1 to it isn't going to change anything. Are there any other numbers that would work like this? Oh, negative infinity, right? If you owe an infinite amount of money and you pay back $1, you pay back $1, you're still in the same situation, right? And this situation is, if you own an infinite amount of money and you earn $1 more, it doesn't really change your situation, right? So infinity is a sort of a nice way to think about it. So that's sort of interesting. So 0, if you do an R to it, I'm just going to call this infinity as a sort of a placeholder because I don't, but it's something that sort of behaves like infinity. So I'm just going to use this as a symbol for this weird configuration of the ropes. Because it's not a number, we have to add something to the number system if we want to be able to have a name for every rope configuration. And this is a real easy one to get to, right? You start with 0, you do a single rotate. Well, this is obviously a physical situation, and if we want to have some way of talking about it, we've got to assign something to it, and none of the numbers we have are going to work. So I sort of have to add something to the number system in some sense to make it work. And it seems to behave like you would think an infinite number might behave. So if we do a 0 and we rotate it, we get to infinity. Or negative infinity, I guess is what I really got here, right? Because it was minus. Yeah, I'll be very precise. we sort of have to treat infinity and negative infinity the same. But I'll do this. Well, what happens if you take infinity and you rotate? Well, here's infinity, so rotate. So that's sort of interesting. If you take our negative infinity or infinity and you rotate, you get back to 0. Okay?